in the interest of time,
Sure.
we are gonna jump to our next panel. Dr. Shetty and everyone on that panel, thank you very, very much. With that, we are going to move to Ted Delvecchia and data management, AI, and blockchain for healthcare, which is the next track that we're going to do a deep dive in. And I will let him take it away with introductions to get us rolling. Thank you, Ted.
Hey, thank you, Sean, and thank you for the speakers before us. Also, thank you very much to the IEEE Blockchain Initiative, one of our hosts, and of course, Consensus Health, our other host, Sean Mannion and Heather Flannery, terrific folks, and we are grateful to be able to address the group this morning. So we are hearing a lot about, which is obviously very important, devices, infrastructure like networks and technologies, and various items of the hard infrastructure, if you will, with regards to this particular theme. And our track is focused on something very fundamental, and it's data, right? It's the integration and interoperability of data. It's the access and use of data, and it's the trust and value of data, where it's created, when it's created, et cetera. So the complexities associated with all of the elements that you've seen and our excellent presentations and all are necessary to understand and explore in this comprehensive program via this virtual event. Our group is focusing on creating an industry utility. Think about what SWIFT as a protocol did for the financial sector, right? An industry utility that basically supervises a standardized protocol for data encoding and for logic execution with trust across massively distributed AI and application ecosystems, if you will, at scale. Right? So think about an industry operating system, if you will, from the enterprise to the edge. As we saw earlier in our keynote presentation, healthcare is very similar to technology in terms of its evolution, right? We had back then, it was a single IBM computer, and I'm an IBM vet, so I'll throw that acronym in. And then, of course, now everything's highly distributed now where we can get Raspberry Pis and small devices from NVIDIA that have more processing power than rooms of computing equipment. And the data that are created at that level, right, are very important. So we believe from enterprise to edge, a standard protocol, and that's our thesis, will allow for advancements to really accelerate. And something's going to have to break the logjam. We're not going to wait for every single organization to do this on their own. And certainly, in some cases, not to suggest they're not a key part of this, but the government, influences, perhaps from a regulatory perspective, will be helpful, but certainly not from a technology perspective, in my humble opinion. So, look, in our collaboration at Symbotics, in this quest to build this operating system, we've got a number of collaborators. Today, I'm very, very happy and proud to introduce three of them. And what I'll do is introduce the individual, pass it along to that person for a quick intro and a little bit of a perspective on why and how they're participating with this event and this entire initiative. And then I'll introduce the other panelists. And then what we'll do is, for the interest of time, we'll not do any slides today, and we'll just do a conversation, until like the gong show, we're pulled off, and we'll appear next time. So first up, I'd like to introduce Dr. Thomas Arjuna, my colleague, friend, and co-collaborator from MIT. Thomas, could you pop on your camera, or at least your speaker, and introduce yourself and give us a short perspective? Might be still muted. He was on. All right, well, while Thomas is figuring out what's going on, computers are really hard, right? We'll move on to my next colleague, who I can see right here on the screen here, a very close friend. He's also working with me at the IoT community on a very similar initiative. It's all connected. Dipto Chakravarti, and Dipto from Amazon. Dipto, why don't you fire up and give us an intro and give us a short perspective?
Thank you, Ted. Hope you can hear me. Give me a thumbs up if you can hear me, my audio. So it's an honor to be here. I'm at Amazon and run a group on AI for voice computing and how do we interact with computers via voice. And my background is I've spent about 5 years in the IoT community group when it was just about 5 people. Now we have about 24,000 members. Met Ted and a number of you through that initiative. Prior to Amazon, I ran a joint venture for called Rexostar that was jointly owned by Merck, Boeing, Rolls-Royce, Lockheed, Raytheon, a very small startup owned by a large number of companies. And before that, I've been at 3 different startups which ended up exiting to 3 different public companies, CA Technologies, Novell, and IBM. So Ted and I go back to our IBM days. Happy to be here. Delighted to talk to you about some of the experiences in AI and blockchain. And I presented at the IEEE conference last year on blockchain as well. So I'll share some of those learnings with you. With that, I'll hand it back to you, Ted.
Thank you, Dipto. Appreciate you being here and looking forward to your comments. We'll throw some questions out to start things in a moment. I'd like to introduce our next panelist, another co-collaborator and a serial entrepreneur. Tom Anderson is CEO of Devio. And Tom, would you fire up and give us a quick intro and perspective, please?
Great, thanks, Ted. So I'm as Ted described, an entrepreneur. My first business was a robotics business. In that business, I raised about $34 million, took the company public, created a 3D touch device that added a very realistic sense of touch to computing. Licensed about $100 million of video game development that we sold with the hardware, and ultimately, to make a long story short, sold our IP to Facebook. So that was my first business. My current business, and why I'm on the panel today, is Devio. I'm the founder and CEO of Devio. And Devio is a blockchain company. We saw just enormous opportunity 4 or 5 years ago in the blockchain space. To me, blockchain is one of the few technologies we'll see in our lifetime that really fundamentally changes computing on par with the internet. Where the internet was a disruptive platform that lets people transfer data, blockchain is a disruptive platform that lets people transfer value. And if you look at it at that most basic level, that's where I saw kind of world-changing implications. So we started Devio to really focus on blockchain implementations, particularly for real-world business use and global level deployment. We created an alpha level network 3 years ago that we benchmarked at 8 million transactions per second. Our costs are 7 orders of magnitude less than a lot of other platforms, that type of thing. So it's a really exciting technology, and really excited to be on the panel today.
Excellent. Thanks, Tom. Again, we'll fire things up in a moment. I see Thomas got back on. It must have crashed on you. Is that what happened?
Well, I was just wondering, maybe that previous presentation on the Mac, like, where is this stuff? I need it now, So
I
yeah.
You're going to tell me MIT's network was down.
So sorry for the delay.
Please, why don't you give yourself a quick introduction? That way
Sure. I'm Thomas Arjuna from MIT Connection Science. We've had several projects in the area of data and data science. And so this topic of health data and edge computing and privacy and, what are we going to do going forward for the new sort of future health infrastructure based on decentralized technologies and blockchain. So this is all near and dear to our group right now. In fact, my boss, the prof, an hour ago talking about taxation on blockchain-based assets, right? So this is kind of very much an area of interest for us.
Excellent. Thanks, Thomas. And for those folks, Thomas and the Connection Science Group at MIT run a Friday coffee session. I've had the great pleasure of being part of that as part of our collaboration. Thomas and I have also co-authored several papers on data, blockchain, AI, and healthcare. So you get the thread here. So why don't we stay with Thomas for now? And Thomas, can you, comment a bit on data trusts for personal health data and, the technology assists about cooperatives and things that are popping up now?
Sure. Yeah. So this is a perfect topic right here. So when the COVID pandemic hit last year, and suddenly everybody wanted to do mobility apps and tracing apps. So suddenly everybody like saying, well, we need to have access to people's mobile data, and suddenly people are saying, well, where is this data, right? So we've been looking at the notion of data cooperative. So what is a data co-op? If you guys are familiar with your weekly market, market cooperatives, right? So the idea is that you would like to enable and empower individuals to utilize copies of their personal data, medical data, location data, financial data, in whatever possible means, that the user can use, today. And remuneration is not necessarily monetary for the end user. The benefits, include, insights about their own, behavior, insights about the neighborhoods, and so on and so on. And so, to give a concrete example that we like to use, take Uber drivers, in Boston. Right now, the data really is controlled by Uber, the company, in a centralized manner. But what if each driver could have a copy of their, driving history, locations visited, and so on? And what if they could put it into a repository which they control? Now, question becomes, well, doing analytics just on one data store is not going to give you much. But if you have 50,000 drivers and they collectively get together in this data cooperative, like a credit union, essentially, where they pool together their data, you can suddenly run interesting analytics for their own benefits, such as comparing, prices paid per mile driving in the south of Boston versus north of Boston. So you move this idea to medical data, right? Just like banking data, individuals will not have the capacity to manage their health data. But what if you have these groups of cooperatives whose job in life is really just to maintain and curate data and run algorithms for the benefit of the members? Some health data could be, well, give me, the average, exercise distance, taken by people aged, 40 and older, in inner Boston, right? That's useful data that a lot of people would like to know. Individuals would like to know. People who design cities and towns and smart cities, they would like to know that as well, right? So how do you enable these interesting insights that benefit communities, societies, and individuals themselves across the board? Health data, mobility data, and so on. So we call that data cooperatives. Other people sometimes call it data trusts, but effectively it's like a co-op or a credit a credit union or whatever they call it in the banking sector.
Yeah, no, so I think what you're raising is an excellent point, Thomas, in many ways, that the disparate sources of data and the volume of data are increasing, exponentially. I mean, I think I've read some studies now that are suggesting in the next 3 years, up to 50% of clinical data will be spun up at the human in the moment, right? So how do we process that, compute that, and then also transport, operate on it, across the continuum while maintaining trust and security and privacy. So I'm going to ask Tom Anderson, who's done some excellent work on the digital identity side of things, to comment on that, if you may.
Sure. One thing I'll mention real quick on what Thomas was saying, I think what he was describing to me is the future of identity information and people being in full control of their information. And I think society is going to shift to a point where it's less about the information itself and it's more about the control of the information. And I see that people will have self-sovereign control in order to use their information however they want. So what Thomas was describing, I think, is a really powerful concept. And technologies like blockchain, I think, can lead people there. For what we've done on identity, that's the main premise. The idea is that people are in full control of their identity. It's all private information. I think you still need to have a situation where third parties, verify information. But the idea in our system, just as an example, is that you have a third party that verifies information, gives you a token. Once you have that token, then you're in full control of that data. And then you can use that to verify the information with somebody else. You can send a message that gives irrefutable proof, mathematical cryptographic proof that a third party verified this information about you. And you think of things like identity theft. I think we're going to look back, years from now at that concept and think, that's crazy. Like, why was the information itself important versus the control of the information, for one example?
Excellent. Yeah, the flow and control is critical. That's why we suggest a sort of a supervisor for a standard protocol across the waves. So Dipto, you and I have been chatting a lot about in a lot of our collaborations about the linear relationship, if you will, between trust and value of data, most specifically in healthcare. Would you like to comment on that in light of what Thomas and Tom just brought up?
Sure, Ted. Thomas's call out on really on that's the future for identity access, and Tom's call out for how it's less about the data and it's more about the control. In terms of, the value is tilting from the data to the control. It's almost from the content to the container. That's the first call out. It's not the content itself, it's the container. Whether you put the container in a virtual container or a physical container, it's the same story. It's how, if you can get to the container, and people who actually are trying to steal information are not trying to open the container. They're not trying to open the door. They are trying to just move the hinges so that you can get to the access much more easily. And that's one call out. So it's about the container. How do you secure information rather than just the information itself? The second one is with IoT making it so pervasive, the footprint is shrinking, the value is shifting from more to how do you trust these beacons around you. Every hallway you walk through, every camera that takes your picture, you got to trust the system that you're on closed circuit camera, you're on a Wi-Fi being monitored. It's basically you have to build that trust in the ecosystem. You called this out earlier. The ecosystem point of view is really important. And what blockchain does to this is it actually democratizes it. It makes it safe and easy to use, from a third-party clearinghouse standpoint that Tom pointed out earlier. And the other aspect of how really trust becomes the most valuable asset is it's less about security, more about trust. Because these little tiny objects, these especially at the edge, the IoT beacons, the ones that I've seen in some nanometer microns, there's not enough power, there's not enough horsepower to do anything other than you got to just trust it. And that's where the zero trust security model has also really gone into mainstream adoption. Because in healthcare, especially with in the whole workflow from a drug discovery in the phases of clinical trials, it really becomes important that we are able to trust at the edge, and value then shifts from just from the technology or the content to actually the container and how do you enforce and secure information.
Absolutely. No, there's also a number of connotations of the word value, right? Because in the eyes of a patient, if you will, or a consumer, not really a fan of the word patient, but in the eyes of a consumer, the word value is it contextual, is it personalized, is it convenient for me to use, is it secure? Am I confident that my stuff isn't going to be out on the web or something? And it also has kind of connotations, both of these words have connotations on the clinical practitioner side, right? So if you think about trust, is certainly, the practitioner needs to trust the accuracy from a provenance perspective, and the patient needs to trust the interaction from a consent perspective. Thomas, can you kind of chime in along this theme that we're kind of picking up on and think about how blockchain may become, because of its distributed nature, also of its ability to execute contracts at the grain of sand level, if you will, how consent becomes a whole part of all of this particular parade.
Sure. Yeah. So when it comes to medical data, we kind of look at like two buckets of analytics that could be done. So the personalized medicine type, where you just talk about one subject, and so you can do the medical doctor needs to see the actual file, the X-rays, and so on. But then you have these aggregate computations that you'd like to do on a large cohort of patients, whether it's part of clinical studies, whether it's part of broader community research. So the question is, two things. You'd like to keep the data where it is. So there's this open algorithms principles or design that came out of MIT, which is you leave the data where it is and you move the algorithm to the data point. And so what blockchains could do with smart contracts is that you could express the algorithms in the form of a smart contract. So the benefit is that you could use the blockchain itself as a log. Who actually invoked that algorithm against this particular data set, right? So the who, as Sam was saying earlier, the identity and authentication is logged on the blockchain so that the patient can see who sort of touched my data, the doctors can see it, the hospitals can see it, right? So there's this, capability. And then, looking into the future, there's this, trusted execution, systems, hardware such as SGX from Intel, where they promise, confidential computing. And so the vision is that, what if you have, a whole network of nodes in a blockchain where each one of them has this capacity, so that your data going into a node is encrypted, it's decrypted within that sort of black box, or what is called a TEE, it's computed, and then it's erased, by the hardware. So that's kind of a promising future direction, where you're combining data privacy requirements with hardware capable confidential computing on distributed ledger systems, blockchain systems and DLTs.
Yeah, we're seeing a lot of TEE concepts pop up, trusted execution environments such as address space isolation and other methodologies. IBM just came up with a hyperprotect protocol, if you will. And to pick up on this thread, Tom, can you relate all of what we just talked about with regards to, because you're an expert in blockchain, you're actually coding blockchain stuff, right? So, and developing new models here. So why do you sense and offer to our audience why blockchain is a good technology? I mean, I think people just assume because we hear a lot about the hype and so on, but why don't you go into some of the details from the technical perspective, please?
Sure, yeah. I think Dipto made a really good point about trust. If you look at the medical space as a whole and medical records, arguably one of the biggest challenges is ultimately trust. And the reason I say it that way is, if patients are in full control of their identity information, and identity is not just who you are, but it's what you've done, where you've been, who you're with, what medical tests you've gotten. It's just everything about you that's personal, that's personally identifiable information or protected medical records. So if people are in full control of that, how do you then have doctors access it? How do you have insurance companies access it? How do you have pharmaceuticals access data that they need to? Companies in general, enterprises don't like to have their private data on somebody else's servers. And so the idea of creating a system where you can maintain privacy, not just for individuals, but for businesses, but have a multi-collaboration, platform where everybody can access the data that they need, include RBAC types of systems where you have, access to who should have access to it. To me, that's really addresses one of the biggest challenges across the space in medical. And blockchain fundamentally, is it's a database, or a data store more precisely, and it's a large scale time ordered database. So a traditional database, keeps track of state. Blockchain keeps track of all of the history that gets to that state. But so that's valuable in maintaining data and running things like AI and machine learning, against data sets. That's perfect for a AI algorithm, because you have all the history getting there. But blockchain also typically has decentralized operations and decentralized consensus. So that means many different parties can all interact and run the system, which allows you to create a trusted system where there's no central authority overseeing transactions. It's also very good with security, which is a primary need for medical data in particular. It's also a great system to be able to enable that self-sovereign control of identity. So blockchain as a data store has certain characteristics that I think are unique compared to other databases that really address some of the biggest problems in medicine.
Yeah, and I think I like that self-sovereign control of identity. It's sort of that anonymity, if you will. So if my identity is anonymous, and you also, to tie, Tom, your comments earlier about blockchain is not just a distributor of secure data, but also it shares value, right? So I think that you've just poked on, and I'll ask you to probe a bit further, and then have Thomas and Dipto also join in on this, is, what about creating stores of value over time, right? And then maybe even moving towards a new economic incentive eventually, right? For consumers and patients to perhaps adhere to their drug regimen, or perhaps start to consider lifestyle choices, because as we all know, SDOH and other concentric elements of impact on a person's health is tremendous. So could you perhaps think about what the vision of the future might be?
Sure. Yeah. So as I said, kind of in the beginning, the internet was a disruptive platform that lets people transfer data, and blockchain to me is a disruptive platform that lets people transfer value. And so again, when you look at that most basic level, value can mean a lot of different things. It can be medical records, but it could also be, payments. It can be records that are audited for financials. You could have, multi-party collaboration, not just on understanding the data, but handling payments and analyzing risks and fraud and things like that. So blockchain has a lot of the characteristics that you would want for a more automated system. And that ultimately, I think, is a lot of what it ultimately comes down to is automation. Like, you'll be able to have a trusted system where anybody can audit, the chain. You could have, for example, a public backbone where you have multi-party collaboration, but, side areas or shards, independent networks that are private for businesses to run on that seamlessly interact with that kind of public network. And then if you start to integrate smart contracts where you automate aspects of operations, like payments or sending records, you can automate a lot of those things in a way that you can assure it's done in the right way. That government or regulatory entities can audit everything's happening the right way. Everything can be done efficiently. You can remove FTEs for a lot of the automation, and free up people to do what they do. Let doctors be doctors and not have to worry about a lot of the mechanics doctors have to worry about these days. So yeah, automation and just integrating all of the different types of value transfer across smart contracts really, to me, is a pretty bright future for medicine.
Absolutely. Thomas, you want to add to something like that?
Sure. I'm looking at the interesting comments from Jim there. Thank you, Jim. So Jim Sinclair brings up some interesting questions, right? This is confidential, basically privacy in the sense of GDPR with respect to DLT. And so, I kind of need to qualify when I say DLT or blockchain, whether it's private permissioned, versus, public. So as Tom was saying, the idea that having my medical data out there in a public, permissionless blockchain, that's not going to fly. But I was thinking more of an internal, private blockchain network or DLT network that's shared by the relevant entities, such as hospital networks, that I'm a member of, and also the different data cooperatives that I'm a member of, right? So that's and thank you, Jim, for plugging trust over IP. I encourage folks to follow that link. That's interesting work being done over there in the Linux Foundation.
Yeah, the Linux Foundation has several. They're also part of that, launched the CCC, the Confidential Computing Consortium, as well as the Trust over IP. Dipto.
I would say that look at LinkedIn. LinkedIn is a killer use case for using blockchain where recruiters and people seeking jobs can talk privately. Right now, it's a public piece of it. That's the kind of community you build with blockchain. And I predict that blockchain is going to grow in two different variations, and there's going to be enough difference of opinion where we have permission blockchain and open blockchain, very much like how private cloud and public cloud evolved and then eventually homogenized these days, because blockchain's chassis of the blockchain, which is the hyperledger, which is the actual ledger, there are 2-3 different implementations of it, and depending on how much sponsorship it gets, it'll move forward. One way to look at it is, the convergence of blockchain and AI is pretty inevitable. That I deal with it every day because both deal with data, both deal with value. Blockchain enabling the sharing of data between the big guys and the small guys. You don't have to be having a lot of advantages. Like it democratizes that advantage. That's what blockchain is doing. It democratizes the advantage, cuts out the middleman, and then AI builds on it by using the analytics and the insight that you pull from the data. The AI is pulling the data out, and blockchain is making the data more democratized so that everybody can use it, everybody can flow with it without having to figure out how to secure it, put a padlock in front of it, to the point where you yourself cannot get to the data, your own data. And I'm sure all of us have had that situation where you've resorted to either sharing passwords or building a password manager to the point where your data is so secure that it takes you time to get to it.
Yeah, Jim Sinclair also just popped back in again, and I love the line of thinking here seems to resonate with our audience. And he just talked about that common utility, suggesting trust over IP is a critical kernel for all of that. Dipto, before we kind of move on to the other guys here, so I've heard you use in our other collaborations the term Internet of People vis-a-vis the kind of things we're working on, Internet of Things. Can you comment on that in the scope of our theme this morning?
Sure. Internet of People, we all know, but Internet of Things is going to have its Internet of Things, which is IoT. The three fundamental differences where we have to deal with is the size. The footprint is microscopic, so you can't encrypt, decrypt, and there's not enough juice, not enough horsepower to do that. Therefore, blockchain-like technology is an easy option. The second difference is power. These are tiny beacons if they don't even have a battery to back it up, it just sends out beacons. So there is keep that in mind for Internet of Things, because the chip in your refrigerator or the chip in your car, that has a power backup, but the ones in the field in the process control, they don't have any backups other than a solar panel maybe. The third one is connectivity. IoT is more about connectivity. Internet had to deal with security, but security and connectivity are like inversely proportional to each other. One is an anti-pattern of the other. One tries to connect, the second one tries to keep whether to keep the connectivity with air gap mode. So those are the key call outs, and trust becomes ubiquitous in terms of driving value, which is what Ted keeps coming back to every day. And I love that lens of looking at it. It's what's going to be fundamentally different for Internet of Things than it was for Internet of People.
Thank you, Dipto. Excellent as always. Jorge Ferraro has asked us a question. I'm going to toss to Tom. Can you come up with a couple of practical use cases for blockchain in healthcare?
Yeah, I think when you look at the long horizon, blockchain will be the type of technology that carries everybody's medical records, right? And it'll be the foundation for where all kind of medical records tie in and data. But shorter term, it takes time to get to that kind of end state. And so you look for areas that really kind of leverage the need that you have, that blockchain can solve shorter term. So the areas where you have particular privacy concerns, I think is a good area. Areas where you have auditability needs, and regulatory compliance needs are a good fit. So one application we're working on right now is cold chain applications, even related to medical data. So things like transporting vaccines or blood for gene therapies or organs and transplants. If something goes wrong in a blood transport for a gene therapy, someone can die, right? So it's a very highly regulated area. It's got high consequence, and it's got high value as well. And so linking in blockchain where you can track temperature over time using IoT sensors, where you get a mutable, auditable log of temperature. Vaccines is another place where that's really valuable. Track supply chain, where you can have many different entities all interact with the system. Those types of problems that have those characteristics, where blockchain, I think, is a low-hanging fruit, will be some of the first application areas where it's used.
So Gora data has been also kind of answering some of the questions, and to the questionnaire, to the person who's asked this question, as a group, this particular track is developing a matrix, and we're using a simple 3x3 cost, experience, and quality, right? To make, and then also down the other side is interoperability, access and use, trust and value. So, if you wish to add to this, and I'll close with those statements in a minute or two, but we're looking for that stuff because we don't know what we don't know. We think we know some stuff, but there's a lot we don't. Tom, there's another example that came up from one of our audience members about contract tracing, and actually Devio has one right now. Don't they using blockchain?
Yeah. So contact tracing is a great example. So thanks for that question. So when the pandemic hit, we had been building for 4 years really a very solid privacy system. In a lot of ways, you could think of it that way. And one of the biggest challenges for digital contact tracing is privacy. You know, a lot of the apps that we're spinning out, you know, we're keeping track of where people are, but then privacy really becomes to the forefront. And so there's two big challenges, I would say, for digital contact tracing versus manual contact tracing. One is privacy, and that's where blockchain, you know, comes in. So it's a great, you know, use case. The second is participation percentage. And so, you know, it's really difficult. Like even in Germany, which has had kind of the best performing, you know, contact tracing solution, you know, they were struggling to get above 25%, and it's just not enough participation to make contact tracing, you know, digital contact tracing work well. So the approach we took was to actually have hardware devices. Actually, I've got one, you know, so we have these little wearables that you can wear. They keep track of where you are. All of the information of who you've been around goes into your public address or your wallet in the blockchain. Then if you get sick, you can say that you got sick, anonymously report that, and then everybody else that was around you who has their information in privately of who they can compare against that record and be notified that they were around somebody that got sick. So if you and I went to lunch yesterday and we spent an hour together and then I test positive the next day for COVID-19, you should get a warning that you were around somebody for an hour at an average distance of 3 feet. You likely were exposed, don't go into work that day. And so what we've done is we focused on working with enterprises where they can say to their employees, you should use it, and you get 100% participation in meaningful contexts. And we spoke with the CIO of a Fortune 500 company that said, I would love to have digital contact tracing. I would love to get people back to the office, but I don't want a bunch of my employees' private information on our servers. I don't want that liability. And he said, if you could solve that problem, we can move ahead. And if you can't, we won't, right? So privacy in that case was a gating factor. And blockchain gave a great solution for that problem. And we were able to move ahead, and we're deploying, tens of thousands of units for digital contact tracing now. Because
yeah, I mean, it makes sense. Yeah, the whole ethical side of things, you know, the anonymity, right? The identity management is core to most of all of this, you know, acceptance, adoption, and value, if you will, to the whole circumstance we're talking about in this entire initiative under IEEE. So in the interest of time, what I'm going to do is I'm going to hand it to Thomas and then Dipto and Tom for a couple of closing remarks, and then I'll just wrap things up. Thomas?
Sure. Yes. So I think just echoing some of the words of our group, earlier, edge computing and data being controlled by individuals, I think is going to be the future, and we need to figure out, what structure is needed, legal and social, and so this idea of a data cooperative, following just like the credit union model. And very few credit unions actually run their own infrastructure. They typically outsource it. So there's this, question in adding in, privacy of computation. So, sending the algorithm to the data points where it is and getting it computed there and taking it back. And so blockchain has a number of roles. Just to answer one of the questions there from Jorge, if you could just use blockchains to log access, that would be good. But, step one, and then Tom, brought up a whole bunch of interesting questions beyond that. So I think, I think we've covered quite a lot today in this, in this set of Q&A. So thank you for the people who are asking these very good questions. I don't have all the answers, but we're working towards it.
Absolutely, Thomas. You're getting a number of thumbs up from the audience. Thomas, also another Thomas just gave you a thumbs up. Dipto, closing remarks?
So look, the surface area is going to increase, and more the surface area increases for the patient records or in healthcare data becoming easily accessible. Blockchain would be the scheme, and the AI will be the mechanism on that scheme, so that you can move the data from whether it's to your private server or a public server or at the edge. That we won't have any control over, but what we can control are the mechanisms that it be reliable. And because we focus 90% of the time on building a solution, but when you train the solution to work in a way using AI, that's when it really becomes a repeatable, rinsable process. I'd like to just end by saying we have lots of, like Thomas said, we don't have all the answers, but we know the known knowns are the facts, and the known unknowns are the intuition, and the unknown knowns are the questions, and the unknown unknowns, which is where some of the opportunities we are all working towards. With that, I'll hand it back to you, Ted.
Very good. Thank you, Dipto. Tom, closing comments.
Sure. I see a few other questions in the chat. So one thing I'll offer is if anybody has blockchain questions, you can email me support@devio.io. Happy to answer any kind of ongoing questions. And then the final kind of parting remark is it was a pleasure meeting you, Thomas. Nice to see you again, Dipto. We did another conference or another panel. And I want to give thanks to Ted. It's a real skill set to be able to manage panels and take people through and kind of keep things flowing. And I've been working more and more with Ted, very bright fellow, really knows the medical space. So it was an honor to be invited. And you did a great job again, Ted. So thank you.
Gosh, Tom, thank you so much. You, all three of you fellows, thank you so much for your valuable time and feedback. I'm sure everyone is much more informed now because of that. To the audience, please join our track, right? We're looking for collaboration that this is all about. Challenges to what we've presented or are pursuing with regards to our, standardized protocol that's supervised, so like an operating system concept, extensions to our ideas. I think at the end of today's session, that Sean and the IEEE folks have put together. It's going to be a call for papers. Please bring them, as Tom has already solicited, to the bear. And then as a closing remark, we have launched a open source community project. Think about the center, if you will, of a Venn diagram. And as you can tell, we have big tech with us. We have several organizations, some of which were mentioned earlier with regards to collaboration. So we have industry players, and then we also have research and science behind us, MIT and several other organizations. So that Venn diagram all kind of cross-sects into our open source community project, and we're committed to ESG. So please join us. This is about changing the world and making our society much healthier. Thank you for listening. Thank you very much, Sean.
Okay.
Thank you,
Excellent.
folks. Thank you, Tom, Dipto. Thank you, folks.
Thank you, Ted. Thank you, panelists. That was a wonderful discussion, and thank you, audience as well. There was a lot of great comments there. And as Ted noted, these are tracks that we are doing deep dives in with panels today. But these are the tracks that we're going to invite a call for papers in just a bit. And so